Chapter Review, question number 7. Energy consumption is claimed to be a good predictor of gross national product. An economist recorded the energy consumption X and the gross national product Y for 8 countries. The data are shown in the table. Calculate SXY and SXX. So in part A, we need to calculate SXY and SXX. Let's write the formula for SXY and SXX here. So SXY is equal to sigma XY minus sigma X into sigma Y divided by N. That is SXY, and SXX would be sigma X squared minus sigma X the whole squared divided by N. So we have the two formulas in place. Now there are a lot of calculations we need to do. We'll start with calculating sigma XY. So for sigma XY, we have X value multiplied by Y value. So we have 3.4 into 55. Then we add to it 7.7 into 240. And then we add to it 12 into 390, and so on and so forth till we come to 131 plus 131 multiplied by 1900. So that gives us our sigma XY. So let's start by writing the value of sigma XY, which is 666,045. That was sigma XY minus sigma X. So sigma X is all the X values added. So I've already calculated these values. Sigma X is 467.1 multiplied by sigma Y. Sigma Y is all the Y values added. So all the Y values added is 7,805 divided by the total number of entries, which is 8. So if we calculate that, we are calculating here SXY. So we'll write here SXY for clarity. And when we calculate SXY, we get 210,330.5625. That is our SXY value. Now let us calculate our SXX value. So for SXX, we require sigma X squared. So we take X value, square it, 3.4 square, add to it 7.7 squared, add to it 12 square, add to it 75 square, and so on and so forth till the end. That gives us sigma X squared. So when we calculate that, we are calculating SXX, and now we are doing sigma X squared. We get 43622.85. 43622.85 minus sigma X. We have already calculated earlier. Sigma X was 467.1. So 467.1 the whole squared divided by 8, and that gives us 16350. 16350. So with that, we answer the first part of the question, which is SXY and SXX. So we have calculated SXY and SXX, which is our answer to part A. Moving on to part B. So the part B says find the equation of the regression line of y on x in the form of a plus bx. Now when we need to calculate the regression line, all we need to do is to calculate the value of A, calculate the value of B, and then just plug it in into the equation. So let's start by calculating the value of B. Since we have the Sxy and Sxx already, we know that our B is equal to Sxy divided by Sxx. We have already got our values of Sxy and Sxx. When we divide these two, we get 12.8642. So that is our B, 12.8642. And that gives us the value of B. Moving on to finding A. So we have y is equal to a plus bx. If we make a the subject of formula here, by taking the term bx to the other side, we have a is equal to y minus bx. So let's write that. We have the average value of a is equal to y minus bx. So we take the average values of y and x here, and we have already got the value of a here with us. So average value of y is the total value of y divided by the total number of entries. So let me write the total values of x and y here, which I have already calculated. So the total value of x was, just 1 second, 467.1, and the total value of y was 7,805. Okay, so now if I want to find the average value of y, it is the total value of y, total of all the entries divided by the total number of entries, which is 8. So 7805 divided by 8. So 7805 divided by 8 minus the B value that I have already calculated here, 12.8642. 12.8642 multiplied by the average value of x, which is 467.1. That is the total of all values of x divided by the total number of entries. And that gives us the average of a value, which is equal to 224.5. 224.5. Now since we have our b value here and our a value, to find the equation of the regression line, which is here, all we need to do is to plug in the a and the b. So let's do that and find our equation of regression line. So we have y is equal to a, which is 224.5, plus b, which is 12.8642, into x, and that is the equation of regression line. So that answers for part B, question number B. Moving on to C, estimate the gross national product of a country that has energy consumption of 100. Now energy consumption is the x value. So all we need to do is to plug in for x 100 and to calculate the gross national product, which is the y value. So we can use the equation of regression line here. So we are moving on to part C. We use the equation of regression line to calculate y value. We have 224.5 plus 12.8642 and multiply that with the x value given here, energy consumption of 100, and that gives us with the Y value or gross national product of 1511, which is a rounded answer. So that answers for part C. Moving on to part D, we have to calculate the estimate energy consumption of a country that has gross national product of 3500. So here we are given the Y value and we have to calculate X value. We know that regression line works best when we calculate the X value. We use the X value to calculate the Y value. But in part D, we are doing vice versa. So we are plugging in the value for Y. So for Y, we plug in 3500 and equate it to the regression line, equation of the regression line, to calculate the unknown X value into X. So when we work this out by 3500 minus 224.5, and that divided by 12.8642, that leaves us with the value of X. And once we have the value of X, that is equal to 255, which is a rounded answer. Okay, so that answers for part D. Now in part E, we need to comment on the reliability of the answer. So we already know for the first fact that equation of regression line is best used to calculate Y value given X, which is not the case here in part D. We are given Y value to calculate value of X. So this is one point. The other is that the value 3500, which is the value of Y, is well outside the limits of the data. So if we observe the Y values, we have it from 55, and the value 3500, as we observe, is well outside the range of the Y values that we currently have. So we can write that value of Y is equal to 3500. Value of Y is equal to 3500 is well outside the limits, and therefore answer is unreliable as it involves extrapolation. Therefore the answer is unreliable as it involves extrapolation. And that answers for part E of the question.